Okay, this is my Project5 demo video, and we're gonna start off with the first step showing AWS instances. So this is my main instance, the one that we've been using all quarter, and this is the master, and this is the slave, and these are their respective public IP addresses, the ones that I'm gonna hopefully ping. And this is the GCP, Google Cloud Platform, with the external IP ending in 28.4. And yeah, so they are all here, and I'm going to show you my instances that I have SSH'd into. And we're currently in the file that the log.txt file should be in. And as you can see, we're not hard coding anything. There's no log files in here. And so we're going to start the JMeter test for the single instance with HTTPS 10 threads. So as you can see, 10 threads, and we're going to run it for infinite for 3 minutes. And we're running it from the CSV file, the query load.txt. And that's getting a title from the CSV and putting it into the title. And these are the graph and results tree. As you can see, we're hitting port 8443. So this is HTTPS. So let's actually just run this first. And I can go over it while the timer runs. So we're going to wait until 3 minutes. So as you can see, it's 10 threads, HTTPS, and it's hitting. This is our main. So this is for single thread testing. And if we take a look at the graph result tree, you can see that it quickly goes up with 10 threads, obviously, with the average of currently 92 milliseconds per response time. And these aren't being used right now. So, and if we look at each response, you can look at the requests, and they are indeed going to 8443. And this is like the format. So the title is being input here, the year, direct, and these are just my defaults. If you leave them blank, that's fine. Okay. So we're just gonna let that run for 3 minutes. As you can see, these are all uniquely generated from the CSV file. And we are just looping through infinitely because there are 10 threads and they finish the CSV file pretty quickly. Suppose I can do a quick yeah. So as you can see, we can see that there's no file in the master or slave because we are hitting the single instance in the main. And we're hitting the 8443, not the 80, which is the load balancer, or port 80, sorry. I'll let it run for 10 more seconds and then stop it. Okay, we're gonna stop right there. And obviously when we stop it, there's like 10 threads that didn't finish, but that's fine. So we're gonna take a look at the graph results. So the 91 millisecond average seems to be holding. And show you again, there is no log.txt file here, but in the main instance, if I can find it, there is now a log.txt file. And what we're going to do is sudo chmod 777 this. Now we can grab it. I'm going to go to my file manager and go to this command prompt and then copy the scp command to the main instance. And all we're doing is putting it in here. So the log.txt file is here. And once we drag it in here, we can bring up this other command prompt to do, all we have to do to call the log processing script is python log processing.py log.txt. And these are our TS and TJ values, so 1.4 and 1.3 milliseconds. Okay, so we're going to stuff this into the single HTTPS really quickly because we're done with that. Put these away for now. And as you can see, there's nothing on the slave, nothing on the master. And we're going to do really quickly remove this one, and now there's nothing on the main. Okay, now we clear this and clear this. Now we move on to the second bullet point, which is testing the AWS load balancer with HTTP and 10 threads. So 10 threads, infinite loop, same thing. And then HTTP, we're hitting port 80 now for the load balancer. And these are the same parameters, and these are not started. So we're going to start here. And what we should see from the instances is that there's nothing in here because it's just the load balancing, and there should be two log files, one on the master and one on the slave. Yeah, so we're just going to let that run for 3 minutes as well, as stated in the Piazza. 2 to 3 minutes was okay, as long as the graph plateaus, which is a good time to show the graph. Yeah, so the graph shows similar response results with 91 milliseconds. And these are all response codes and the requests. As you can see, it's going to 3.143.33, which is our main IP, public IP address. And these are all unique titles, as you can see. As you can see, most of these are valid responses with no errors. And yeah. Let it run for 30 more seconds and then we'll stop it manually. I mean, the graph already plateaued, but I'm just gonna let it run for 3 minutes. And we're gonna stop that right there. So as you can see, it averages 91 milliseconds per response time. And yeah, only the N where we stopped it manually are those requests invalid. So now let's see if our inference was true. There should be nothing in the master, or the main instance, instance one, sorry. And there should be 2 log files because they are spread evenly here. And that is what we have. So we're gonna, again, sudo chmod 777 log.txt, sudo chmod 777 log.txt. Okay. Then we will bring up our file managers again and go here. Oh no, wrong one. Go here. Still the wrong one. Go here. Okay. We're gonna SCP the file from the master first. And this should show up in our CS122b file. Yep, there it is. We're gonna rename this to master. Drag it down here. And then now we're gonna SCP the second log file from the slave. Okay, and then rename this one to slave. Now, once we drag it down here, we're gonna do the combine.txt. So as you can see, 244, 242, all it does is propagate them together so we can run the log processing without issue. And that should be this one. We'll just run the log processing on log.txt. And these are our results. So this was the first one, and this is the second one. Once we're done with that, we can drag them into AWS. Yeah, so we have 1.55 milliseconds for TJ and 1.6 for the TS on the AWS load balancing, which goes against our usual assumptions, as we assume load balancing would lessen the load and make the response times quicker. But I assume there's some work being done with the connection pooling that would make the single instance just fast too. So now we're going to start with the third bullet point. So now we're actually hitting the GCP IP, and we're going to hit port 80 for the load balancing. So as you can see, this is GCP. I'm going to start it. Oh, actually, no, I have to remove. So I'm going to remove these text files or these logs. I will show that there's nothing here, nothing here. And just for redundancy, obviously GCP won't hit the main instance, but just to be sure. Okay, so these are empty. Yeah, so we're going to start the GCP and let that one run for 3 minutes as well. And yeah, as you can see, it's propagating already. And the average response time is actually slower as expected because GCP is not on the same private IP server farm as Amazon. So there's probably some traffic in between those two when it's load balancing. And what we should see again after this, because it's load balancing, is it hits the master and slave and loads it with log.txt. Okay. Go over the code of combine.txt really quickly. All it does is take 2 files or it takes all the text files in the directory and combines them into one. And then in log processing, All we're doing is splitting it, stripping it, taking the integer values that are logged by the server, servlets, or more specifically, the search endpoint servlet, and then averaging those values. And then obviously converting nanoseconds to milliseconds here. Okay. So you can see these are valid responses. These are requests. We're hitting the 28.4, which should be the external IP of the Google Cloud Platform. Again, we're going to stop this at 3 minutes again. Ten more seconds. And stop. Okay, so these are all valid responses until the end where we manually stop it and it doesn't complete its request. So as you can see, nothing hits the main. And then let's take a look. Whereas before they were empty, now there are 2 log.txt files as expected. Now we're going to chmod these so we can get permission to SCP them out. Okay, now we're going to do the actual SCP. Oh, wrong one. Look at our file manager. And again, we're going to copy the master SCP to take out the master file. Yeah, and now we have our file here, named to master. And then now we're going to SCP into our slave and grab that log.txt file out. As you can see, it should come in here. Yep. Rename slave. Okay. Now we're going to do the combine.txt, should generate a log file, 214, 212, and if you propagate them together, it's a log.txt with 426, and it should be the same lines. Let me go to my log processing. And the average TSTJ times are similar to the AWS load balancing. It's 1.6 and 1.53 milliseconds. And if we take a look at our graph, because we didn't really go over that, average was 103 response time in milliseconds, of course. And yeah, that is it for my demo video. Thank you.